Okay, here's some more example. Lithium and fluorine, LiF. We're going to give you the formula. You have to give me the name. Remember, lithium, group 1A, fluorine, nonmetal. You know the charge on that is -1. Therefore, the name for the metal will be unchanged, and we change fluorine to fluoride, and we just call that lithium fluoride. We don't have to specify the ratio because we know those charges from the periodic table. That same thing is going to be true for this barium telluride. And then look at this more complicated one, Sr3N2. To balance the charges, we have to have 3:2 ratio. But in the name, because the metal is a representative metal, we know the charge on that is going to be 2+. And if we go find nitrogen, the charge on nitrogen is going to be 3-. So we just say the name strontium nitride, and we know the formula has to be Sr3N2 because of their locations on the periodic table. So if I give you a quiz, barium with 2 iodines, you're going to find it's a metal with a nonmetal. The metal is represented by finding its location on the periodic table. So the name simply is going to be barium iodide. We have to change that iodine to iodide, showing that it's a salt. So barium iodide number 2. Aluminum and oxygen. Find them on the periodic table. Aluminum is a metal, oxygen is a nonmetal. Aluminum is a representative metal. We know the charge on that is 3+, so we don't have to specify the ratio. So we'd simply call that aluminum oxide. Number 3. Aluminum. I dropped an A there. Aluminum oxide. You don't have to specify the ratio in the name because representative metals and nonmetals, those charges are known. Now, when you move on to transition metals, the case is a little bit different. Transition metals can take on a variety of charges. So it makes sense, doesn't it, that we now, so this is a metal with a nonmetal, that's still going to be the salt, but now the metal is a transition metal, and we don't know what the charge is. So we're going to have to specify what that charge is in the name, because iron could be 2+, it could be 3+. Lead could be 2+, it could be 4+. Tin could be 2+, it could be 4+. Manganese could be 2+, it could be 3+. It could be any one of those. So in the name, when we name it, we have to specify the charge. And we use what's called this stock formula to do this. We actually write down what the charge is. We use the stock system. Classical, we're just not going to even talk about that. We're going to use the stock system where you just write down what the charge is, and you have to do this very precisely when you are putting the answers into Wiley Plus. As I've shown here, I'm going to put in the iron 2. I have to say it's iron 2 is the ion I'm using. Iron, I spell it out, and then I don't leave a space and put the left paren, and then I put Roman numeral 2, and then right paren, and then I leave a space and I'll put whatever the anion is associated with it. Okay? So the example I have here is cobalt and chlorine, and the salt in particular I am talking about is cobalt with 3 chlorines, 3 chlorides, right? Because this is a salt. You go to the periodic table, you find cobalt, you find it's a transition metal. You go and you find chlorine, and you find out it's a nonmetal, and then it has a charge of 1-. And because there are 3 of these chlorines, the charge on the cobalt must be 3+. It's a 1:3 ratio. Therefore, it must be cobalt 3+ with chloride. And so the name's going to have to, we write down or say, we'd have to say cobalt 3 chloride. If you write it down, cobalt, no space, left paren, Roman numeral 3, right paren, space, chloride. Now you don't have to say how many chlorides there are. You don't have to say cobalt trichloride or anything like that, because you're saying cobalt 3, and you know the charge on chloride is 1- from its location on the periodic table, so you don't have to specify that in the name. Now there's a bunch of examples in your book, problems, you should work those. Practice, practice, practice. I've given you some homeworks, practice those. Now I'm going to skip through this classical nomenclature. It's in your book, you should be aware of it, but we will not use it. Just be aware. We will use stock system only. Okay, talked about metals with main group, main group metals, and nonmetals. Transition metals and nonmetals, and then that third type of binary compound that you run into, nonmetals with nonmetals. Let's review first. So we've got magnesium and we've got chlorine, and it's MgCl2 is the formula. You've got to find those on the periodic table. You're going to find magnesium is a metal, but it's a representative metal. And then you know the charge on chloride is -1. But because the magnesium is a representative metal, from its location on the periodic table, no memorization, you find it on the periodic table, you know all you have to do is say the name is magnesium chloride. You don't say magnesium dichloride. You don't say magnesium 2 chloride because it's a representative metal. We know the charge is 2+. We know the charge on chloride from its position on the periodic table is 1-, so we just say magnesium chloride as our example. Second example, palladium and chlorine. The name, because it's transition metal, we have to specify the charge. So I'd be giving you this name, palladium 4 chloride. You'd want to tell me what the formula is. Because the palladium in the name says it's 4+, and you look on the periodic table, find out chloride has a charge of 1-, it must be palladium Cl4. Choice number 1. Okay. Now remember, our strategy, there's 3 types of binary compounds you're going to run into. The first one, you say, is this a metal with a nonmetal? Or is it a nonmetal with a nonmetal? If it's a metal with a nonmetal, determine whether that's a main group metal or a transition metal, and you name it accordingly. But that third type, nonmetals with nonmetals, those are not salts. They are close to each other on the periodic table. It's not a metal with a nonmetal. They don't steal electrons. They share electrons. And that means the ratios they can be a variety of ratios. And I've shown some examples here, just focusing on the nitrogen-containing compounds. NO is a stable molecule. NO2 is a stable molecule. N2O is a stable molecule. N2O5. These are all stable molecules because they share electrons. They don't form ions that have to cancel their charges. So we have to have now a naming system that specifies those ratios. It has to be in the name. So to start with, if you have a nonmetal with a nonmetal, the nonmetal that's furthest to the left on the periodic table is the one you put first. So, for example, we have NO2. I would call that nitrogen. That's because it's on the left side of oxygen. So it goes first, and I use no change. And then the one on the right, again, we have to put that IDE suffix in there. So it would be nitrogen oxide. Now, because the ratios can be any crazy ratio, I mean, there's just a variety of ratios that are possible, we have to actually put in those ratios in the name as well. And to do that, we use Greek prefixes to indicate the number of each one. So you're going to have to know these Greek prefixes. Mono, di, tri, tetra, penta. You won't go this high, but hexa and hepta. These are the Greek prefixes that are used to specify the numbers. So in the example we just did, like I said, NO2. NO2. So I can't just say nitrogen oxide. I've got to specify the ratio. So I would say mononitrogen dioxide. Now, if you have mono, you don't have to say mono. If you don't put any Greek prefix, it's assumed to be 1. So I would actually just say nitrogen dioxide. But if the compound I was talking about was N2O5, then I would have to say dinitrogen pentaoxide. Now, this is a nonmetal with a nonmetal. Still a binary compound, just 2 elements, but a dinitrogen pentaoxide. I have to specify. So there you go. The example N2O3, that's also another stable molecule. You have to say dinitrogen trioxide. It's a nonmetal with a nonmetal. These are molecular compounds. They do not steal electrons and form ions. They share electrons. Now what about CO2? Well, you know that one. That is carbon dioxide. Now that's versus carbon monoxide. Or there's a C2O3 compound, dicarbon trioxide. Nonmetals with nonmetals can form a variety of compounds. What about P2O5? Well, that would be diphosphorus pentaoxide. Now, you drop the, you don't know, it's correct either way, but typically a chemist would call that diphosphorus pentoxide rather than pentaoxide. So what about BF3? Well, we don't have to say mono for the boron, but we first recognize this as nonmetal with nonmetal. So we're going to call that boron trifluoride. And carbon with 4 chlorines, again, we don't have to say monocarbon. We just say carbon tetrachloride. And then PF5, that simply becomes phosphorus pentafluoride. So nonmetal with nonmetal, you've got to specify the ratios. So now let's mix them all up. Okay? Strontium with oxygen, lithium with phosphorus, copper 2+ with nitrogen. I'll leave that for you to test yourself. First of all, locate them on the periodic table, right? The first one, strontium with oxygen, well, that's a metal with a nonmetal. And the metal in this case you find on the periodic table, well, that is a representative metal. So when I give the name, I don't specify the charges or the ratios. I'm going to be in the same case with lithium and phosphorus. I find them on the periodic table. It's a representative metal with a nonmetal. Now I go down to copper with nitrogen. Copper is a metal, but it's a transition metal. It has multiple charges. I have to specify what it is. So the formula, copper 2+ with nitrogen. Nitrogen has how many charges? It has 3 minus, right? So you're going to have to figure out the ratio. I'll go the other way. I'll give you the formula. You tell me the name. Same idea. You're going to look at the compound. You're going to look at metal with a nonmetal. And if it's a metal, is it a transition metal or a representative? And then you name it accordingly. Give you the name. You have to be able to tell me what the formula is. These are the problems you're going to have to be able to do. And I'm going to cut it off there. We'll pick this up on Friday. We'll give you some more practice. We'll talk about those polyatomic ions. But that's enough information for you to get going on this homework. Do your best. Work a lot of problems. And then on Friday, we'll go through lots and lots of these problems and see how it goes.